Machines not only that learn, but evolve their own architecture. As a process of learning, evolve an architecture, not under our control, only partially under our control, but under the control of machine learning.
Yeah.
I'll tell you another thing that I find awesome. You know this Google thing that they taught computers how to play chess?
Yeah.
They taught computers how to play chess, not by teaching them how to play chess, but just having them play against each other.
Against each other. Self-play.
Against each other. This is a form of evolution. These machines evolved. They evolved in intelligence.
Mm-hmm.
They evolved in intelligence without anybody telling them how to do it. They were not engineered. They just played against each other and got better and better and better. That makes me think that machines can evolve intelligence. What exact kind of intelligence, I don't know. But in understanding that better and better, maybe we'll get better clues as to what goes on in our own intelligence. Among the few neuroscientists I've ever talked about this, they are pretty convinced that the brain functions classically, that it is not intrinsically a quantum mechanical system, or it doesn't make use of the special features, entanglement, coherent superposition. But all systems are information processing systems.
It certainly feels, consciousness and intelligence feels like magic. If we look at it, information processing, what are the emergent phenomena that come from viewing the world as an information processing system?
If you ask me about physics, my thoughts may be worth something.
Yes.
If you ask me about this, I'm not sure my thoughts are worth anything. For example, you have neurons which detect vertical lines. My conclusion is that we won't get it right that way. That by machine learning, we will evolve systems, and we may start to discover mechanisms that have implications for how we think and for what this consciousness thing is all about. Originally, string theory was invented, and I know that I was there. I was right at the spot where it was being invented, literally, and it was being invented to understand hadrons. At that time, the late 60s, early 70s, it was clear from experiment that these particles called hadrons could vibrate, could rotate, could do all the things that a little closed string can do.
Mm-hmm.
Its value is that it's mathematically rigorous in many ways, and enabled us to find mathematical structures which have both quantum mechanics and gravity. Entropy to become important. For a small system, entropy is not a good concept. And entropy is something which emerges out of large numbers. It's a probabilistic idea, it's a statistical idea, and it's a thermodynamic idea. Thermodynamics requires lots and lots and lots of little substructures. Okay, so it's not until you emerge at the thermodynamic level that there's an arrow of time.
So what do you think of the recent first image of a black hole visualized from the Event Horizon Telescope?
The fact that there are black holes which collide is not a surprise. And they seem to work exactly the way they're supposed to work. Will we learn a great deal from it? I don't know. We might. But the kind of things we'll learn won't really be about black holes. Why there are black holes in nature of that particular mass scale and why they're so common may tell us something about the structure, evolution of structure in the universe. Mm-hmm. But I don't think it's going to tell us anything new about black holes.
What are your hopes for quantum computers? So machines that are based on, that have some elements of leverage quantum mechanical ideas.
Yeah. It's not just leveraging quantum mechanical ideas. You can simulate quantum systems on a classical computer. Simulate them means solve the Schrödinger equation for them, or solve the equations of quantum mechanics on a computer, on a classical computer. But the classical computer is not a quantum mechanical system itself. Oh, of course it is. Everything's made of quantum mechanics, but it's not functioning. Level. It's not functioning as a quantum system. It's just solving equations. The quantum computer is truly a quantum system which is actually doing the things that you're programming it to do. To my mind, as far as I can tell, the great power of quantum computers will actually be to simulate quantum systems. What exact kind of intelligence, I don't know. But in understanding that better and better, maybe we'll get better clues as to what goes on in our own intelligence.
What life and intelligence is.
Yeah.
Last question. What kind of questions can science not currently answer and may never be able to answer?
Yeah. Is there an intelligence out there that underlies the whole thing? You can call them with the G word if you want. I can say, are we a computer simulation with a purpose? Is there an agent, an intelligent agent that underlies or is responsible for the whole thing? Does that intelligent agent satisfy the laws of physics? Is it made of atoms and molecules? Yeah, there's a lot of questions.